Hello, everyone. My name is Babeanu. I'm an identity solutions architect with Nulli. We're a consulting firm based out of Canada, but we do lots of work internationally. So I just wanted to start today by asking you a question. I mean, we're all identity professionals here, um, but do you remember the first time you wrote your first access policy? I mean, I'm going to assume that some of you at least have written an access policy before. Can't see a show of hands, but do you remember when it was? For my daughter, she was 11 and she wrote it on her door. And it's still there to this day, 11 years later, because I think she used the most permanent marker known to humankind. It's a very interesting policy. It reads that anyone can enter under one condition. You got to like zombies and vampires and werewolves, etc. And at the very end here, there's even a super user called Elise that has apparently all access to the room. That's kind of an interesting one. Um, Nowadays, access policies start to look exactly like this, or even more complicated than that. And this is particularly true in B2 star environments. And that's what I'm going to talk to you about today. Here's what we're going to look at. We're going to talk about B2 star and what I mean by that. We'll have a look at the challenges of these environments. We'll have a look at the problems and look at our current tools and provide a solution. We'll talk about graphs. And we'll have a look at the value added of graphs and how to start. All right, so B2 star, B2 what? What do I mean by that? Well, we're all familiar with B2C, of course. It's when a business sells products and services to a consumer. That's easy. We're all familiar with B2B as well. It's when a business sells products and services to another business. We've all done that. What about B2B2C? Well, this starts to become a bit more interesting. Now we have two businesses, A and B, that partner together and to sell the same product and services to the same consumer. It's a recent trend. I mean, it's a model that emerged in the last few years. There's some companies that do that, actually quite a lot of them. So here are some of the key elements of B2B2C. It's a partnership between the companies. It's a sales channel as well as a business model. Consumers know they're buying from business A, and there's a clear differentiation between the companies, and it's the same consumer in both cases. Now, here's an example of B2B2C. Let's say that we are a retailer, and that's our core business, and so we sell products in supermarkets. Now, we partner up with an online delivery and ordering system in order to sell our products to the same consumer. Now, the advantage for the consumer is that they can choose to buy the products at the supermarket or online. Great. But there's no limit to the actual number of partners that we may have. Why limit to two? Why not have three or more, or B to B, and then it would become B2B to B to C or B2B to star. This is where we're getting into B2 star. And when we get there, it's an interesting thing to think of businesses as plugins to our core business. After all, we have our core business that sells products and services, and all we're doing is adding capabilities to that business, like online orders, delayed payments, and there's no theoretical limit as to the number of partnerships we may have. Now, the important thing here is that this is all to sell the same products and services to the same consumer. Now, things start getting a bit more complicated, as I'm sure you realize, because again, a lot of data needs to be shared across all of these different businesses. A more realistic view of the situation would be this, where consumers don't always use all the layers, all the plugins in our B2 star environment, but kind of pick and choose. Some consumers may just keep buying from our core business, while others may order online. Others may utilize our delayed payment system, and everything may possibly go through IAM. Now, again, there's no limit to the number of layers here, but as you can see, things start to become really, really complicated because of this data sharing and all the accesses that need to be granted in all the cases. For the data itself, as I mentioned, it needs to be shared. In particular, the consumer data needs to be shared. There's various options for that. One is to synchronize the data across all those businesses. Another is to share it from one business or from the other. But in either way, all those consumers need to be shared, as well as actually the product and services, or at least those that pertain to the plugin. That's where it gets complicated. All right, so we've introduced B2 star. What are the problems then with this? There are two main categories of problems: volume of data and data complexity. Now, as I'm sure we've realized, the volume of data has increased dramatically in the past few years. In fact, it looks like an exponential growth. We're in the zettabytes now, and these are projections for 2024. Interestingly, before 2010, the amount of data worldwide was pretty much neglectable. So in recent years, tremendous amount of data, and this is particularly true as well for IAM data. We have now hundreds of millions of identities if we factor in devices and all of that. The second problem is data complexity. This is a little diagram from the Atlas of Economic Complexity. It depicts various industries throughout the world and how they are interconnected. Now you can realize that the data generated by all these industries is also very much interconnected. It's actually a geographical view. If you look, you can look at it from east to west or west to east. Here's North America and the Americas. We have Europe, the Middle East and Africa, and Asia over here, and these are all the industries. All of this data, of which IAM is part of, becomes highly hyper-connected. So in short, we have a staggering volume of IAM data with hundreds of millions of identities. We have devices, services, APIs, people, what have you. The data becomes more and more complex. It becomes hyper-connected. Access control becomes a real challenge. We have role explosions, scope explosions. I'm not even citing here things like privacy concerns, and consent management in this environment becomes really challenging. And besides that, in my years of experience helping clients out with problems, there are some missing pieces. There are things that we don't really have good answers for. One is how to build a consumer or a user 360-degree view, or determining who has access to what exactly. I've seen numerous organizations struggling with just that question. They don't have a proper answer. How to do segregation of duties. And what is the impact of a change? Can you do impact analysis? What would happen if you remove the role, or if you remove the permission, or if you changed something? And what if your identity system could provide recommendations? Wouldn't that be nice if you could recommend products, or maybe entitlements, or things like that? That's something we don't have right now. Our tools so far in the field, these are in my experience, we've been storing identities in two main ways, and I'm sure you all know this: SQL databases and LDAP directories. Now it's interesting to go back down a little bit down memory lane. SQL was created in the 70s. It all started with a paper by Edgar Codd titled "A Relational Model of Data for Large Shared Data Banks." Again, this is 1970. I'm just qualifying the large here. Anyway, this led to Oracle V2, which was the first commercial RDBMS in 1979. For LDAP v3, our current still in use version of LDAP dates back to 1997. Just to put things in perspective, here are the technologies in use at that time. SQL and relational databases were created at the time where we're still using punch cards to program mainframes, which kind of explains to me why we're modeling relationships as tables and columns. Anyway, that's just me. LDAP v3 was finalized, so far, at the time when this modem right here was considered quite fast. I was quite happy with that modem myself. And this is what we have to contend with. Again, we're greatly out of our league. The problem with relational model and the volume and complexity of data is when we need to find the relationships between one entity and another that are a few hops away. How many joins can you make on tables that have hundreds of millions of rows? It breaks down very fast. Same thing with LDAP, just doesn't work for all the type of complexities and relationships that we have nowadays. Specifically, consider again that before 2010, the amount of data that we had was pretty much neglectable. Yeah, but I can hear the comments, but nowadays in our modern cloud environments, the databases are state of the art, everything's super fast. Yes, but how fast can you go really? The problem is not the infrastructure. The problem is the paradigms we are still using nowadays. Isn't it time for an upgrade? So again, this is the problem we're trying to solve. Imagine you have not 4, but like hundreds of plugins like this. with millions of users, millions of products, it's really hard to scale this with the current tools we have. A solution that I would like to propose, and we've been advocating it for some time, if you've seen other of my sessions, is graph. So first of all, why do we still use the tools we're using? We're using them because of relationships. That's the main reason. Relationships are important, and that's why back in the 70s, they realized that we needed to model them. But as I mentioned, it's really hard to model nowadays relationships that are a few hops given our current databases. LDAP also is a relational model. It models parent-child relationships. That's great, but it's very limiting. We need to model all kinds of relationships. So it's really hard to do. Besides complexity, an interesting experiment here. If you Google data complexity and click on the images button, this is what you get. It's interesting to note that this is where I think IAM is now. We're staggering in the dark. We have a lot of data we don't know how to make sense of. And here's what everybody else is doing. Everybody else is using graphs to tackle complexity. We should embrace it, I think, anyway. So what are graphs? Graphs express relationships. Graphs handle complexity. These are two simple examples of two really basic graphs. They are simple graphical representations made of two elements, nodes and relationships, arrows. The nodes are labeled with nouns generally, and the relationships are labeled with verbs. So they makes them really easy to read. Graphs express relationships, graphs handle complexity. Here's a little comparison here of an ERD and a graph that express the same idea. On the left, we have customer purchase product tables, and on the right, we have a customer who bought a product on a date. Which one's easier to read? Be honest now. Now, of course, this represents an instance of a transaction, whereas this represents a model, but try to represent an instance of a transaction in a relational database. Yeah, much harder to do, right? I mean, at least to read for a non-techie. And this actually brings up another benefit of a graph. It empowers more users to use them because they're readable. So how then do graphs tackle our two problems of complexity and volume? Let's have a look at complexity first. Here's an example of a graph. This is a graph representing Game of Thrones. It actually represents the relationships between the various characters in the Game of Thrones series. Whether you like the book or the TV series, these are the characters. Now, let's stretch our imagination a little bit and imagine that this graph represents our B2 Star environment. So for instance, we are down here, we are Stark Incorporated, and this is our employees. Over here, we have our customers as well as our resources that we're trying to protect and expose to some of our clients. Great. Over here, we have our first partner company called the North Co, and this is their employees. Now, the first thing you'll note is that some of their employees are also our customers. It makes sense because we're partners, so they like our product. Over here, we have our partners, customers, and resources. And right off the bat, we can notice that over here in this segment here, we have our B2B2C model because we have customers that are customers of both. Now, we also partner with a second company called Dragons Inc. Now, right away, we can notice that some of their employees need access to some of our resources and some of their resources as well, maybe for support. Over here, we have Dragons Inc. customers and resources. And we see that there's some B2B model environment right here. And B2B2C, here's our B2 Star environment where all our clients and products and services mingle together. So you'd be really hard pressed to model something like that with anything but a graph, I think. So we can model complexity as a graph. So given that, how do you tackle the access management problem? In a graph, you can, for example, express an access policy as a path. Here's a simple example of a graph. We have a Jane Doe user who subscribes to a read feature of a device, for example. If we can find a path from Jane to the device, then we can grant access. Now, the relationship directions are important, of course, but we can match them exactly as they are. So that's how you solve your access problem. All right, so what about volume? Well, let's have a look at our example again, graphs and volume. And let's imagine that we have an access request for which we need to find a path. In this particular case, John wants to access Renly. And as we see, it's a 1, 2, 3 hop path. It's a path that needs to go through 3 hops. Easy as that. Well, here's what it would look like at a larger volume. This is a graph that represents about 140,000 nodes. So it's still a small graph by old standards. What it turns out that the same access request takes exactly the same amount of time because it's still a 3-hop query. So it doesn't matter how many other nodes there are, your access request still has only 3 hops, therefore it will take exactly the same time. So graphs scale really well at large volume. Compare that with a relational database, for example. Great, so what is the value added of graphs? What are the missing pieces? Well, let's start with our user 360-degree view example. If you have, well, I mean, there's 2 cases. Well, first, an easy case is you have an attribute to correlate your users with. That's pretty easy. What you can do is create another node and relate all these identities together to create this unified 360-degree view node. Great. Now, if you don't have this attribute, which is usually when the problems arise, well, graphs provide all kinds of embedded algorithms that are mathematically can help you find the matches. For example, graph similarity algorithms can help you find similar groups of nodes. Then you can apply some rules. You can track the context of your users and see if their behaviors are similar. You can use some AI and machine learning techniques in order to infer relationships. All of these are much, much easier to do in a graph because, again, a lot of graph databases are actually embedding those algorithms out of the box. What about impact analysis? Well, it's pretty easy to assess the impact of a change in a graph. For example, what happens if I delete this relationship here? Well, we can see right away that in that case, all these nodes here become orphaned or detached from anything else. What if I delete this node? Well, again, pretty easy to see that in that case, we end up with a lot of orphan nodes over here. So impact analysis becomes way easier. This one I like particularly. Now, again, we're looking here at something that is identity data combined with resources and access data. And here we can do recommendations. For example, we have a user here that bought 2 products and another user that bought one of the products. Well, we could recommend the second product to the first user. I mean, this can be applied as well to entitlements. If a user has this and that entitlement, maybe we can recommend some entitlements to a user. All of these things are pretty well, I mean, suited for graphs. Graphs are actually used a lot of times just for that use case. And so it's about time that we should use we should empower our identity professionals to use those types of techniques as well. So how to get started with graph then? Well, first of all, you need to recognize the need or the opportunity. Then you need to create a graph and load it and add data to it, of course. But the most important thing here, the 3rd point, is that you can complement your legacy systems for the time being. I mean, you can add them to add capabilities to your existing systems. And while you use the graph, you can slowly phase out your legacy systems until you're very happy with the graph. There you go. That's how you would get started. In fact, actually, I think there's maybe a use case where LDAP stores might still be relevant even going forward. Is just to bind users. LDAP store being very fast for reads because they're optimized for reads. But you can then still use a graph in combination. That said, in that case, I would use a very flat LDAP store and not worry about making hierarchies in there. Anyway, that is all I had for you today. Thank you for your attention, and I would be really glad to answer any questions you might have. And I think for that, you probably need to use the chat window.